All right, in this mini tutorial, I want to talk about the use of log operation in the context of solving a derivative. So in this case, we have a problem y is equal to 2x plus 1 to the power of 4x, and we want to take derivative. Now, over and over, I see many students think that they can just apply the kind of typical derivative operation that is applicable to power function. We call it the power function rule. So for example, if you have y is equal to u to the n power, y prime is n times u to the n minus 1. So for example, y is equal to x to the 5th power, y prime is 5x to the 4, right? But the problem here is that this n right here is a constant, which means is an actual value, is a number. In this case, we have a function as an exponent. So this is not applicable to this. Again, by the way, these kind of rules are simply shortcut specifically applicable to a very specific kinds of function. So in this case, because they're qualitatively different types of functions, you cannot use a shortcut pattern and apply to this. So this is just a pattern for power function. Okay, so all that is to say is that we have a problem here. Now we want to take advantage of a log, so this is called a log operation. So why log? Why? Why do we use the log, right? We take advantage with the kind of couple things. One thing is that we learned before that ln of b to the c power can be written as c times ln b. So this is the idea of something complicated in the exponent that is getting in the way of our solution. We can use this to kind of bring the exponent down to the base position. That's the reason number one. Number two, for the derivative problem, is that we know that derivative du of ln u is equal to 1 over u. So we know the derivative ln u is 1 over u. So if we can somehow use ln on this to get the exponent down to the base position, then one of the elements that's showing up will have ln expression in there. And if you have ln expression in there, no fear, because we know that derivative ln u is 1 over u. Those are the two reasons. So let's go ahead and try to solve this problem. We want to try to solve for y prime, but we cannot solve this directly. But what we can do is we can operate ln on both sides of the equation, because this is a function on the left side of the equation, a function on the right side of the equation. If I use log on the function on the left and also on the right, this is okay. So we say ln operating on y, not times y. Okay, some students often make mistake thinking that this is ln as a thing multiplying by y. No, ln is an operation apply on the y. Okay, and we do ln applying this on 2x plus 1 to the power of 4x. Now the next step is go ahead and simply write it this way, right? So it's writing it this way, and we notice that you have ln of this thing to the power of 4x. Applying to this rule, 4x goes to the front, so 4x times ln applying on 2x plus 1. So that means you have a function here, you have a function here, you have a function here. We can go ahead and find the derivative implicitly. So derivative of ln y is 1 over y times dy, because we're This is a differentiation operating on y, variable y. In this case, we have this function times this function. This is a product, so we need to use product rule. So u times v, remember to write the u, y equal to u times v, then y prime is u prime v plus v prime u. So this is u, and this is v, right? So u prime v, u prime will be 4, but because it's operating on an x, so it's dx, times v, straightforwardly write this out, plus v prime, v is ln 2x plus 1, so is 1 over 2x plus 1. But remember Chen rule, there's a function inside, the derivative is 2, and it's operating on the x, so it's dx, and then times u, v prime u, so u is 4x, so 4x is right here. Okay, now I'm gonna clean this up a little bit. All right, so I have 4 ln 2x plus 1 plus 8 8x 2x plus 1, and then the whole thing dx, because I can factor out the dx. So now I have dy over dx, because I can divide both sides by dx. I got 4 ln 2x plus 1 plus 8x over 2x plus 1. And then I can multiply by y. But what's y? Well, y was defined as 2x plus 1 to the 4x. So I can go ahead and multiply and substitute the original function back. So here is your final answer. See you next time.